Welcome to our guide on thermogravimetric analysis and differential scanning calorimetry, commonly known as simultaneous thermal analysis. In this tutorial, we will explore the principles, operation, applications, and limitations of TGA-DSC, a powerful technique used to understand the thermal behavior of materials. TGA measures the mass changes of a sample as a function of temperature, or time, under a controlled atmosphere. DSC allows us to precisely correlate changes in mass with changes in heat flow. Combination of these techniques offer a deeper understanding of the chemical and physical processes, endothermic or exothermic, occurring within the sample. The thermogravimetric analysis instrument usually consists of a high precision balance, oven, gas system, and sample pan, also known as crucible. The sample inside a crucible is heated from an ambient temperature to 1000 degrees Celsius in inert or air atmosphere. The weight change occurs due to the chemical reactions happening under experimental conditions. To demonstrate how to use the machine, we will use a polymer sample. Thermally and chemically stable crucibles are typically made of aluminium oxide, but also from platinum or graphite. Depending on the sample material, different size of crucible is used for the experiment. First three crucibles are made from aluminum oxide, have different sizes, and are used for TGA-DSC analysis. The lid is needed for a DSC analysis. The small hole in the lid is a safety measure in case heating the sample leads to gases being released, which could lead to overpressure and explosion of the sealed crucible. The last crucible is made from aluminum and is used only for DSC analysis, where under applied conditions, thermal decomposition of sample does not take place. Weigh a small amount, typically 5 to 10 milligrams, of your polymer sample accurately using a microbalance. Make sure you note down the exact weight. Place an empty crucible, referred to as the reference crucible, and subsequently introduce your designated sample. The primary reason to measure the reference crucible is to account for the buoyancy force generated due to the presence of flowing gases, as this force could potentially interfere with the accuracy of the measurement. Ensure the machine is purged with a gas, helium or air. For polymer decomposition, inert gas such as helium is used. Set the flow rate of the purged gas to a suitable level to maintain a controlled environment. The software used for the experiment can be recognized by this green icon. This should open up the software where you can set the experimental parameters. In the box on the left, you can see the queue of experiments that you set up. In the box on the right, you can choose the heating range and rates. This can be done by opening a previously used method and modifying it. After the parameters have been chosen, press Save, make sure that the Run blank curve is ticked, and send the experiment to measure the reference crucible. In the right bottom corner, you can find the Start button. Next, we repeat the process and input the sample name and weight that we previously measured. Make sure that the position number is right and send the experiment to the queue. Now you can observe how the machine automatically picks up the crucibles and takes the measurements. Obtained data could be opened in the data process software, which you can recognize by the star icon. To open the data, click on Evaluation window and open. A window should pop up where you can select the data you are interested in. We can open the graphs, and as shown on the screen, if you take a TGA-DSC measurement, the data will provide information about the weight behavior and heat flow change in time. The heat flow has two negative peaks, which suggests an endothermic process. In case of an exothermic process, we would observe positive peaks. First endothermic process, around 125 degrees Celsius, happens without change of weight, and represents melting of polyethylene. Second endothermic process happens at higher temperature, from 370 to 470 degrees Celsius, and represents the decomposition of polymer, since you can also appreciate a decrease in weight. This technique can be used to perform detailed analysis of thermal behavior and stability of various materials, analyze water content in solids, determine amount of carbon or coke in catalysts, study adsorption properties of various materials, and analyze melting and crystallization behavior of different materials, for example plastics. It is also important to keep in mind the influence of heating rates, since when mass transport is limiting, you may shift from equilibrium reactions. Additionally, TGA-DSC should be used with caution when handling potentially explosive materials and gas mixtures. Lastly, this particular model cannot go to negative temperatures. Using a TGA-DSC is a powerful technique for understanding the thermal behavior of different materials including polymers. By following these steps and carefully analyzing the data, you can gain valuable insights into the decomposition process. This tutorial provides basic knowledge about thermogravimetric and calorimetric analysis. Good luck with your experiments.